add, subtract, and multiply matrices of appropriate dimensions. For this scale, level 1 indicates that we need to be able to add or subtract matrices, and we have to be able to tell when you can't add or subtract a matrix. Level 2 introduces the idea of scalar multiplication before you add and subtract matrices. In level 3 and level 4, we are multiplying matrices, and we will get to that in the next video. First thing that we need to do is figure out what exactly is a matrix. So you may want to pause the video a moment, copy this down. But a matrix is just a rectangular array of variables or numbers, and we arrange them in rows and columns. It's used quite a bit to be able to organize a lot of information, especially think if we had restaurants that we were managing and we were looking at several different vendors for those restaurants. There might be quite a few pieces of information that we would need to arrange in a matrix. It's like a table, but you take out what this is called in the row and in the column. Now, each of the pieces of a matrix are called an element. It's each of the numbers in here. So an example would be 8 is an element, 4 is an element, 7 is an element. We are able to name matrices based off of their dimensions, and we use the row by column. Rows are horizontal and columns are vertical. So row, left and right, columns are up and down. So we would say that this matrix is a 2 by 3 matrix. Now, to enter a matrix into our calculator and to use it for calculations, we need to follow these steps. Once again, you may want to finish copying this down by pausing the video. So in our calculator, the matrix button is located on top of the inverse button here, and we'll use that later on in the chapter, but it says matrix right above it. To access it, we need to press second right before we press that, and we'll get this list. Now, if your calculator is new or it's been reset recently, you may not have anything listed here. It might just be blank. But this is where you will go to be able to call your matrices to use them for any kind of calculations, and you can go over to edit your matrices as well. We'll walk through how to enter a matrix in our calculator in just a moment. But when we are adding and subtracting matrices, we have to have them with the same dimensions in order to be able to add and subtract them. So the 2 by 3 that we were discussing at the top of the page can only be added or subtracted with other 2 by 3 matrices. As soon as the dimensions are any way, shape, or form different, they are no longer able to be added or subtracted. We would just say not possible. And when you add or subtract, you just add the corresponding elements. So the very first element in one matrix is added or subtracted to the very first element in the next matrix. Scalar multiplication we'll get to in just a moment, but it's just where you multiply a number by every single element in the matrix. Think of it like distributive property for matrices. Now, some properties that you may be familiar with in just regular math don't often hold true with matrices. So we're going to go over the ones that do hold true and the ones that don't hold true. You have learned for quite a while that adding numbers like 5 plus 3 is the same thing if we reverse it, 3 plus 5. That is true when we are adding matrices as well. You've also learned something called the associative property, where you could group 3 or more numbers together and you could add them in any order you wanted, and they would still be the same. So for example, if I had 2 plus 3, I could add that together and then add 5, or I could do 3 plus 5, add that together first and then add the 2. Either way, it doesn't matter. That's true also with matrices, that associative property. Let's go ahead and jump into some actual calculations. Before we enter them into our calculator, we need to know how to function with them by hand. So in our first matrix here, we need to label out the dimensions before we're able to decide whether or not we can add or subtract it. I know that you could probably eyeball the ones with adding and subtracting, but it's a good practice because multiplication kind of kicks it up a notch with the dimensions and being able to multiply matrices. So it's a good idea to get really good at your dimensions now when it's more straightforward. So our first matrix that we're given is made up of one row, and it has 3 separate columns. So we would label this as a 1 by 3 matrix. This one has 1 row and 3 separate columns, so it's also a 1 by 3 matrix. This means that I can add these because they have the same exact dimensions. So we are going to be adding matrices by adding the corresponding elements. So the very first element in the first matrix will be added to the first element in the second matrix. So -8 plus 11 gives us 3. For the next one, we'll take the second element and add it to the second element in the next one. So we have 2 plus -7 gives me -5. Then finally we have the last element added to the last element. 6 plus 1 gives me 7. Now what makes it a matrix is adding these brackets on either end. So make sure that you add your brackets. Number 2. This time we're subtracting a matrix. And I really encourage you to, whenever you see a subtraction sign in between matrices, I would encourage you to go ahead and just distribute that subtraction sign to all of the numbers in the second matrix. Because oftentimes what happens is we forget that we are subtracting halfway through. So I would encourage you to take this negative and put it directly in front of all of the numbers. So if there's already a negative there, that would change it to a positive. And what that will do is it will allow us to just combine our 2 terms together, or our 2 elements together, because they're already been distributed for the negative. So what are the dimensions of the first matrix? It is a 2 by 2 matrix because it has 2 rows and 2 columns. Same for the next one, 2 rows, 2 columns, so it's also a 2 by 2 matrix. And let's add the corresponding elements. We have 7 plus -9, that gives us -2. Then -12 plus -6 gives me -18. 15 plus -4 gives me 11. And finally, we have 4 plus 9, which gives me 13. We're not done with our answer until we have added those brackets. For the next problem, we need to identify our matrices with our dimensions. So it is a 2 row and 3 column matrix. And we are attempting to add that to a 2 row by 3 column matrix. So 2 by 3 and a 2 by 3. They're perfect because they match. So we can go ahead and add our like terms. It is a subtraction sign, so you do want to go ahead and distribute that negative to every single element inside. So that makes this a +2, a +18, -8. Obviously, you don't need to make it -0, but a +11 and a -2. That will make our lives a lot easier when we go to combine our 2 matrices together. 5 plus 2 gives me 7. 13 plus 18 gives me 31. Then -6 plus -8 gives me -14. And the second row, I'll just go back to the pink color here. 3 plus -2 gives me 1. -17 plus 11 gives me negative 6. And finally, we have 2 plus 0, which is 2. And we'll make our answer a matrix by putting the brackets around. For our final matrix for adding and subtracting, we'll label our dimensions. It is 3 rows and 2 columns, so 3 by 2, 3 rows, 2 columns. Of course, you guys can probably eyeball those when you're adding and subtracting. Just make sure that you're able to name them as well, because that's how we will do multiplication. So since they're the same, we can go ahead and combine them. We have 8 plus 5, which is 13. Negative 5 plus negative 3, which is negative 8. I'll do the next row. 12 plus negative 15 gives me negative 3. 6 plus negative 8 gives me negative 2. And the final row, negative 7 plus negative 2 is negative 9. And 10 plus negative 6 gives me 4. And to make it a matrix, we'll put our brackets around it. Now, multiplying by a scalar is like distributive property for matrices. So when I am trying to multiply this 3 by this matrix, I'm going to do 3 times 4, 3 times negative 3, 3 times 11, and same thing for the bottom row. So we have 3 times 4, which gives me 12. 3 times negative 3, which gives me negative 9. 3 times 11, which is 33. And then the bottom row. 3 times negative 10, negative 30. 3 times 9 is 27. 3 times 15 is 45. Same thing when you're multiplying by a negative number in front. We have negative 5 times each of these. Negative 5 times positive 6, which gives us negative 30. Negative 5 times negative 8 is 40. Negative 5 times 12 is negative 60. Negative 5 times 5 is negative 25. Negative 5 times 12, negative 60 again. Negative 5 times negative 9, positive 45. Negative 5 times 0, 0. Negative 5 times negative 2 is 10. And finally, negative 5 times negative 7, positive 35. But you're not done until you put the brackets around it. So scalar multiplication, fancy way to say distributive property. Let's take a look at the next one. We're going to kind of put it together, scalar multiplication and addition and subtraction of matrices. Now the work that I need to see for these is the ability to plug them in first. So our first matrix, we use a capital letter when we're naming these matrices. So this B here is our first matrix. So we have 4 times matrix B, 8, negative 1, negative 2, and 7. And then we are subtracting 2 times our matrix A here. 6, negative 4, 3, negative 5. Our first step would be to take care of our scalar multiplication first. So we have 4 times 8, 4 times negative 1, 4 times negative 2, 4 times 7. And you can either distribute the negative 2 to each of these, or you can distribute the 2 and then go through and change all the signs. Either one is perfectly fine with me because you'll end up with a plus sign in the middle. So we have negative 2 times 6, negative 12. Negative 2 times negative 4 is 8. Negative 2 times 3 is negative 6. And negative 2 times negative 5 gives me 10. Once the scalar multiplication has gone, we're going to now add our matrices. Remember, we're just adding corresponding elements. 32 plus negative 12 gives me 20. Negative 4 plus 8 gives me 4. Negative 8 plus negative 6 is negative 14. And 28 plus 10 is 38. Now, we do have a graphing calculator that will do matrices in it. So let's go ahead and practice with that. So in your graphing calculator, you are going to press second and the matrix button. Let me lighten this up just a little bit for you so you can see it a little better. And like I said, yours may have numbers here or it may be empty. Either way is okay. But one, like it said up here, under I can multiply by a matrix by a scalar, we name our matrices with these capital letters. And once you enter in a matrix for that capital letter, we are not going to be able to delete that matrix from there. So we don't need to delete it once we put it in there. We will just continue to type over it when we need to use that matrix again. So let's go ahead and enter in all 4 of these matrices so we can get some practice. So we're going to go over to Edit and press Enter on matrix A. The first thing it's going to do is it's going to ask you for those dimensions. So it is a 2-row and 2-column matrix, so 2 by 2. And you can see mine's already entered, but you would enter 6 and then press Enter, then enter the next element, negative 4, press Enter, and so on until you've entered all of the elements. Once you've entered in your elements, if you have more matrices to enter, then you can press second and matrix again. Go over to Edit and go down to the next matrix. 2 by 2, 2 by 2, and then enter in all of your elements. Do that for matrix C and matrix D. Go ahead and pause the video. Okay, now that we have our matrices entered, your last matrix was on matrix D, and you've entered in all of the elements. Now, it's important that you don't just go straight into typing in here. You need to quit out of your matrices. So we'll press second and quit to get out of our matrices. And now we can practice doing them with calculations. So we have 4 times matrix B, 4 times second matrix, and we want matrix B. That's what this names column is for. It's for when we need to go over to a matrix and use it for calculations. So there's matrix B minus 2 times second matrix, matrix A. And we should have 24, negative 14, and 38. So it's a really quick and easy way for us to check, and there should be no reason for you to get them wrong on the actual quiz or test. You have plenty of time to check it. The work that I need to see is at least you putting it in to the matrix form. So in B, we have negative 8 times matrix C, negative 4, negative 6, 12, and negative 7, plus 2 times matrix A, 6, negative 4, 3, and negative 5. So then our second piece of work that we need shown is we need to show the scalar multiplication. So negative 8 times negative 4 gives me 32. Negative 8 times negative 6 is 48. Negative 8 times negative 12, times positive 12 is negative 96. Negative 8 times negative 7 is 56. Plus, now we'll distribute 2 to all of these elements. 2 times 6 is 12. 2 times negative 4 is negative 8. 2 times 3 is 6. And 2 times negative 5 is negative 10. And our final step is to go ahead and combine our matrices. 32 plus 12 is 44. 48 plus negative 8 is 40. Negative 96 plus 6 is negative 90. And 56 plus negative 10 gives me 46. Let's check it on our calculator since we already have A, B, and C written in there. Make sure that you guys have shown your work because the standard doesn't say use technology to do the matrices. The standard indicates that you need to be able to do the matrix addition and subtraction and scalar multiplication. So this work is proof that you know how to do it. So we want to do negative 8, and we want to do second matrix, and we want matrix C. Plus 2 times second matrix, and this time we want matrix A. 44, 40, negative 90, and 46. For the next one, we have negative 5 times matrix B, 8, negative 1, negative 2, and 7, minus 2 times matrix D, 9, 6, 0, negative 2, 8, and 0. You should see an error here. Even if I were to distribute these out, I still have a 2 by 2 matrix. Even if I were to distribute this negative 2, I still have a 2 by 3 matrix. And I cannot subtract a 2 by 2 and a 2 by 3. This is not possible. If you were to try to do this, it would look like this. Negative 5 times matrix B minus 2 times matrix D, which I don't think I've actually written that one in there. Did I? Yes, I did. Okay, so 2 times matrix D, second matrix, D, and it's going to give you an error, and it'll say dimensions mismatch. When it says that dimensions mismatch, it means that the size or dimensions of your matrices do not match what they need to be for the matrix to do that operation. So we will say not possible. For the next one, we have negative 4 times C minus 5 times D and here we have a similar problem. 2 by 2, 2 by 3, this is not possible.